Something is passing through our solar system right now that does not belong here. It came from another star. It traveled for billions of years through the cold darkness between galaxies, and scientists are calling it one of the most extraordinary objects ever observed in recorded human history. Its name is 3-Guy Atlas, and the more astronomers study it, the more startling the discoveries become. On July 1st, 2025, a telescope in Chile picked up a faint moving dot in the night sky. The NASA-funded ATLAS survey, which stands for Asteroid Terrestrial Impact Last Alert System, was designed to scan for objects that might threaten Earth. But what it found that night was something no one had ever quite seen before. The object was given a temporary name and flagged for further study. Within hours, astronomers around the world began pulling up archive data trying to trace where this thing had come from. What they found stopped them cold. The object was not from our solar system. It could not have formed around our sun. Its trajectory, its speed, and its direction all pointed to one unavoidable conclusion. This visitor had come from somewhere else entirely, from another star, from another solar system, possibly from billions of light years away, or from deep within the ancient heart of the Milky Way galaxy itself. To understand why this discovery is so startling, you need to understand how rare these objects are. Before 2017, no one had ever confirmed that an object from outside our solar system had passed through it. Then came One-Eye Oumuamua, a strange, tumbling, elongated object that briefly visited our cosmic neighborhood and then left before scientists could study it properly. 2 years later, in 2019, came 2-Eye Borisov, the first confirmed interstellar comet, which behaved more like a normal comet and gave astronomers a better look. But 3-Eye Atlas is different from both of those in ways that are shaking up everything scientists thought they understood about objects that travel between the stars. The first thing that makes 3-Eye Atlas extraordinary is its speed. When the telescope in Chile first spotted it, the comet was already traveling at 137,000 miles per hour relative to the Sun. That is fast, incredibly fast. But as it fell deeper into our solar system and the Sun's gravity pulled it inward, it accelerated even further. By the time it reached its closest point to the Sun on October 30th, 2025, it was moving at 153,000 miles per hour. For context, that is nearly twice the speed of the previous interstellar comet Borisov, and more than twice the speed of Oumuamua when it passed through. No object we have ever tracked moving through our solar system has ever moved this fast. 3-Eye Atlas holds the record for the most extreme and dynamically wild orbit ever measured in the history of solar system science. The orbital eccentricity of 3-Eye Atlas is 6.141. To understand what that number means, consider that any object with an eccentricity above 1.0 is moving too fast to be gravitationally bound to our Sun. It will always escape. A perfectly circular orbit around the Sun has an eccentricity of exactly 0. Earth's orbit is about 0.007. Even the most elongated long-period comets in our solar system have eccentricities just barely above 1.0. But 3-Eye Atlas has an eccentricity of over 6. Its path through our solar system is so extreme that from a bird's eye view it looks almost completely straight rather than curved. This object is just cutting through our cosmic neighborhood and continuing on its journey as if our entire solar system is barely a blip in its path. The second thing that makes this comet startling is where it came from. Tracing the path of 3-Eye Atlas backward through space, astronomers determined it entered our solar system from the direction of the constellation Sagittarius, which is the direction of the Milky Way's galactic center. This is unusual because the previous 2 interstellar objects came from a completely different region of the sky. Scientists believe that 3-Eye Atlas may be what they call a relic of the galaxy's cosmic noon, an ancient period roughly 9 to 13 billion years ago when star formation in the Milky Way was at its absolute peak. If that is correct, this comet may have been drifting through interstellar space for longer than our Sun has even existed. It is a fossil from the earliest chapters of our galaxy's story. The third startling thing about 3-Eye Atlas is that it is a comet at all. Oumuamua baffled scientists, partly because it showed no cometary activity, no tail, no coma, no outgassing. It was dry and strange, and its behavior forced researchers to propose exotic explanations for how it was moving. Borisov, by contrast, was clearly a comet. 3-Eye Atlas falls decisively into the comet category. Within days of discovery, multiple observatories confirmed it had a coma, which is the cloud of dust and gas that surrounds a comet's icy nucleus as solar heat causes it to sublimate. NASA's Hubble Space Telescope captured images showing a teardrop-shaped cocoon of dust surrounding the object's solid nucleus. The coma had a distinctly reddish color, similar to what was seen with Borisov, indicating dust consistent with a primitive icy body. But the chemistry of 3-Eye Atlas is where things get particularly fascinating. Scientists using a combination of instruments including NASA's James Webb Space Telescope, the MAVEN Mars Orbiter, and the Sphere-X mission studied the comet's gas production and found something unexpected. The ratios of water, carbon dioxide, and carbon monoxide being released by 3I Atlas were different from what is normally seen in comets that formed in our own solar system. The comet's surface chemistry appears to have evolved and changed throughout its journey as solar heating penetrated deeper into the nucleus. Observations from the Subaru telescope in early 2026 found that after perihelion, the ratio of carbon dioxide to water in the coma had actually dropped compared to earlier readings. This tells scientists that the interior of the comet has a different chemical composition than its outer layers, which makes sense for an object that spent billions of years in frozen interstellar space before being suddenly exposed to solar radiation for the first time. The size of 3I Atlas adds another layer of mystery. NASA's Hubble observations from August 2025 placed the diameter of the nucleus somewhere between 1,400 feet on the small end and 3.5 miles on the large end. That is a massive range of uncertainty, and it reflects how difficult it is to precisely measure an object this small at these distances. Even at the upper estimate of 3.5 miles, it is still a relatively small object on cosmic scales. But what it lacks in size it more than makes up for in scientific importance, because the material it is made of came from another star system and carries chemical information about the environment where it was born, information that cannot be found anywhere else in our solar system. The journey 3I Atlas made through our solar system gave humanity an unprecedented opportunity to study material from another stellar neighborhood up close. At its closest approach to the Sun on October 30th, 2025, the comet came within 1.4 astronomical units of our star, which is just inside the orbit of Mars. At its closest point to Earth on December 19th, 2025, it was still about 170 million miles away, roughly 1.8 times the distance between the Earth and the Sun. It posed absolutely no threat to our planet. It passed through, studied us as much as we studied it, and then continued on its way. What was remarkable about this particular interstellar visitor was how many eyes humanity turned toward it. NASA mobilized an extraordinary fleet of spacecraft to observe 3I Atlas from different angles and distances simultaneously. The Hubble Space Telescope tracked it from Earth orbit. The James Webb Space Telescope analyzed its chemical composition in infrared light. The TESS mission, normally used for hunting exoplanets, had actually captured the comet in May 2025, weeks before anyone knew it was approaching. The Psyche spacecraft observed it from a position deep in the asteroid belt. The Parker Solar Probe watched it near the Sun. The Punch mission captured it from its unique vantage point in space. Mars orbiters, including MAVEN and the Mars Reconnaissance Orbiter, tracked it as it swung past the red planet. The Perseverance rover on the Martian surface turned its cameras skyward to capture it. Even ESA spacecraft, including JUICE, Mars Express, and ExoMars Trace Gas Orbiter, joined the global observation campaign. Perhaps the most dramatic single observation came from X-ray telescopes. In late November and early December 2025, the X-RISM and XMM Newton space observatories pointed their instruments at the comet and detected a diffuse glow of X-ray light surrounding the nucleus. This made 3I Atlas the first interstellar object ever observed in X-ray light, adding another dimension of data to the already extraordinary scientific portrait being assembled by researchers around the world. The data collected from all of these observations is staggering in its depth. Scientists have described 3I Atlas as potentially one of the best observed comets in history. Not just one of the best observed interstellar objects, but one of the best observed comets of any kind, period. The amount of information captured about this visitor from another star could take researchers years or even decades to fully analyze. Every dataset adds another piece to the picture of what this object is, where it came from, and what it can tell us about the universe beyond our solar system. One of the deepest questions raised by 3I Atlas is what it implies about the density of interstellar objects passing through our cosmic neighborhood at any given time. For most of human history, astronomers assumed that our solar system floated through interstellar space in relative isolation. The space between stars seemed too vast and too empty for solid objects to be traveling through it in any significant numbers. But the discovery of Oumuamua in 2017, then Borisov in 2019, and now 3I Atlas in 2025 suggests that interstellar objects are passing through our solar system far more frequently than anyone realized. Scientists estimate that at any given moment, thousands of interstellar objects may be present within the orbit of Neptune, invisible to us simply because they are too small and too faint for our telescopes to detect. As survey telescopes like the Vera Rubin Observatory come fully online, this number of discoveries is expected to grow dramatically. What does that mean? It means our solar system is not as isolated as we thought. Comets and asteroids from other star systems are constantly visiting, passing through, carrying chemical information from their home systems. Some of those interstellar visitors may even have delivered organic molecules or complex chemistry to planets in the solar systems they pass through. The building blocks of chemistry and potentially life itself may be spreading between solar systems on the backs of wandering comets, drifting through the galaxy for billions of years before arriving somewhere new. 3I Atlas has already left our solar system's inner regions and is heading outbound into deep space. It will never return. In a few decades, it will be beyond the reach of any telescope we currently possess, but the data it left behind, the observations gathered by dozens of spacecraft and telescopes from across the entire solar system, will continue to yield discoveries for years to come. Every analysis, every paper, every measurement adds to our understanding of what lies beyond the edge, of our own star system and how connected our cosmic neighborhood truly is to the rest of the galaxy. The story of 3I Atlas also forces astronomers to reconsider how solar systems form and how they shed material into interstellar space. Every solar system in the galaxy went through a chaotic early period when planets were forming, objects were colliding, and gravity was flinging debris in every direction. Many of those ejected objects were sent on one-way journeys out of their home systems and into the space between the stars. Over billions of years, the galaxy has been filling with these interstellar travelers, silent messengers carrying the frozen chemistry of dead or distant stars. 3I Atlas is almost certainly one of those messengers. It was born somewhere, ejected during the violent early history of some other solar system, and has been drifting in the darkness ever since. The fact that astronomers can now detect and study these objects changes the nature of astronomy itself. For the first time in history, we do not have to rely solely on spacecraft missions to study material from other star systems. The material is coming to us. Interstellar comets are, in a sense, nature's own sample return missions, delivering pristine material from across the galaxy, directly into our backyard where our telescopes and spacecraft can examine it in extraordinary detail. What scientists found in 3I Atlas particularly exciting is the presence of large particle jets erupting from the comet's surface. These jets of gas and dust, driven by the sublimation of ices being heated by the sun for the first time in its life, give astronomers a direct window into the interior composition of the nucleus. The material being flung outward from the comet's surface includes chemical signatures that were locked inside since this object first formed billions of years ago around another star. Analyzing those signatures is the closest thing humanity has ever had to directly touching another solar system. Scientists have also noted that 3I Atlas appears to be from what researchers call the galactic thick disk, a region of the Milky Way that contains some of the oldest stars in the galaxy. Objects from the thick disk are typically much older than those from the thin disk where our own sun resides. If 3I Atlas truly formed 9 to 13 billion years ago during the galaxy's cosmic noon, then the chemistry locked inside its nucleus predates the formation of our sun by several billion years. It is older than Earth, older than our solar system. It carries information about a chapter of the universe's history that no instrument in our solar system could otherwise access. A visitor from another star passed through. We were watching. And what we learned has permanently changed how humanity thinks about its place in the universe.